Yeah, good evening, children. Good evening, online students.
Good evening, ma'am.
Yeah, good evening, online students.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. I've shared my screen. Visible, online children?
Yes, ma'am.
Out. Okay, so we started this chapter, a pair of linear equations in two variables, without actually formal introduction. When I checked, all of you had actually learned this chapter. You all agree. You all told me that you had learned this chapter already at school, and Mr. Keshav wanted word problems on linear equations, and he had been texting almost every day. So I directly started word problems. Okay, but that shouldn't have been a problem because all of you had, have got the introduction from school. Now, let's just see that now. Okay. Okay. So we know that a linear equation in two variables x and y geometrically represents a straight line in the Cartesian plane. Okay, an equation of the form ax plus by plus c is equal to 0. Okay, an equation of the form ax plus by plus c is equal to 0 is the standard form of a linear equation in two variables x and y. Geometrically or graphically, this equation is represented by a straight line in the Cartesian plane. Okay, so we know that there are infinitely many points on a straight line. A straight line has infinitely many points on it. And every point on the line is a solution to that equation. That is why we say a linear equation in two variables, one linear equation in two variables x and y has infinitely many solutions. I'll come again. Okay, what is this? Ax plus by plus c is equal to 0. You can compare this with 3x plus, it can be minus also. So 3x minus 5y plus 6 is equal to 0. Okay, so you can see a 3x ax minus 5y plus by plus 6 plus c is equal to 0. Okay, so where a is 3, b is minus 5, and c is 6, right? So ax plus by plus c is equal to 0 is the standard form of a linear equation. Why linear? Because the power of x is 1, the power of y is also 1. The highest degree is 1. So linear. That is why it's linear. Why linear equation? Because the power of x, the variable x is 1. The power of the variable y is also 1. So the highest power is 1. And so the degree of the equation is 1. Linear, because the degree is 1, highest power is 1, so the degree is 1. A linear equation, we understand equation because we have equal to 0. So equation. So linear equation in two variables, and the variables are x and y. So ax, where a is the coefficient of x, plus by, where b is the coefficient of y, plus c is the constant, is equal to 0, is a standard form of a linear equation in two variables x and y. Geometrically or graphically, it's a straight line in the Cartesian plane. We know that a straight line has infinitely many points on it. And a straight line has infinitely many points on it. Now, every point on the straight line will be a solution to that linear equation. Supposing this linear equation. So every point, there are so many points on the straight line, and every point it will be a solution to this equation. That means on the straight line, so supposing you find, you just take a point and find its coordinates, and you substitute the x and y value here, the equation is satisfied. The equation will be satisfied. That's why we say every point is a solution to the equation. Take another point lying on the line, another point, find its address. So this is the x value, this is y value. Put that x value here and y value here. You will see that the value of the LHS is 0. RHS is 0. LHS also will be 0. So that means that point satisfies the equation. So like that, every point on the straight line will satisfy this linear equation. And there are infinitely many points, so infinitely many solutions. Now, if you're asked to write the standard form of one linear equation and two variables x and y, this is what it is, ax plus by plus c is equal to 0. If they ask you to write the standard form of a pair, then you should write one more, no, ax plus by plus c is equal to 0. One linear equation, the first one. If you're asked to write the standard form of a pair of linear equations in two variables x and y, same conditions, two variables x and y, linear equations, but you should write a pair of linear equations. You should write two linear equations in two variables x and y. So that means you should write this one again, right? But how can you write the same thing again? There should be some difference. So what should make the difference? X and y are the variables, so they will remain the same. The coefficients, you must differentiate the coefficients. Write that equation again and differentiate the coefficients. The coefficient of x in the first equation is a1. The coefficient of y in the first equation is b1. And the constant in the first equation is c1. Differentiate the coefficients. Don't write x1, y1. X and y are the variables. They will remain x and y in both the equations. They'll not become x1, y1, x2, y2. The variables are x and y. Okay, so this is the first equation. This is the second equation. In the second equation, the variable is x. Its coefficient is x2. Variable y, coefficient, did I read this correctly? I don't know what I said. In the second equation, the coefficient of x is a2. Again, in the second equation, the coefficient of y is b2. And the constant in the second equation is c2. Did I say it all correctly? So a1, coefficient of x in the first equation, a2, coefficient of x in the second equation, b1, coefficient of y in the first equation, b2, coefficient of y in the second equation, c1, constant in the first equation, c2, constant in the second equation. So this is how you represent a pair of linear equations in two variables x and y. Or this is the standard form. This is the standard form of a pair of linear equations in two variables x and y. All right. Okay. So when you make the graph of these equations, for the first equation, you will get one straight line. For the second equation, you will get another straight line. So when you have two linear equations, you will get two straight lines on the graph paper. When you have one linear equation, one straight line on the graph paper. Two linear equations, two straight lines on the graph paper. Now we are going to study as to how these two lines will behave on the graph paper. What are the possibilities? If you have two lines on the graph paper, what are the different possibilities you can have? So the two lines may intersect. The two lines may be coincident. Coincident meaning they lie one on the other like this. Or they may be parallel. They never meet. They never meet. These are the only three possibilities. Now you will think, what if I have the lines like this on my graph paper? They don't meet on your graph paper maybe, but if your paper was still bigger, you can produce and make them meet. Sometimes when you make lines, see, not sometimes, see, like the lines, if they don't meet on your graph paper, that means the space is not sufficient. If you produce them, they'll meet somewhere. Because these are the only three possibilities. Either they are parallel, they're never going to meet. Okay, or they're intersecting, or they're coincident. These are only three cases possible when we have two straight lines in the Cartesian plane. So either the two lines are parallel, or the two lines are coincident, or they are intersecting lines. All right? Got it? What's the condition for intersecting lines? A1 by A2 is equal to? Is not equal to. A1 by A2 is not equal to B1 by B2. The condition for intersecting lines is A1 by A2 is not equal to B1 by B2. And when we say intersecting lines, how many solution does it have? One solution. So see, how do we understand this? This linear equation, when you take alone, many solutions. This linear equation, when you take alone, many solutions. But the common solution is only one. That's what we mean when we say unique solution. When you take the lines independently, each of them have many solutions. When you take only one line at a time, it has infinitely many solutions. But when we talk about the solution to a pair of equations, when we talk about the solution to a pair of equations, that means we're talking about the common solution. So the solution, so this case where the two lines intersect, we say the two lines have, meaning the two equations have a unique solution. Unique solution because the two lines intersect. When you take the lines alone, they have many solutions. But which is the common solution? Only one. So in the case of intersecting lines, the address of this point is the common solution. That's the only point common to the two lines. That's why we say it has a unique solution. And the condition is A1 by A2 is not equal to B1 by B2. Now, when the lines are parallel, A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. Correct? And when the lines are coincident, so the lines are coincident, meaning the two the equations are equivalent equations. See, like if you have an equation x minus 3y is equal to 5, you multiply this equation by 2 or 3. So you multiply this equation by 3. So you'll get 3x minus 9y is equal to 15. So these two equations are called equivalent equations. So when you make the graphs of these two equations, the lines will be coincident. The lines will be coincident. You have an equation. You multiply that equation by anything other than 0, by any non-zero real number. You can multiply with a negative number, anything other than 0. You have an equation, multiply that equation with any non-zero real number. So you get an equivalent equation. When you make the graphs of these two equations, the original one and its equivalent, you will see that the lines are coincident. Okay, the lines are coincident. So if the lines are coincident, what? The solution, every point on the first line also lies on the second line. When the lines are coincident, every point on one line also lies on the other line. So common solution, all the solutions are common. All the solutions of the first equation are also solutions of the second equation because they're coincident lines. Every point on one line also lies on the other line. So in case of coincident lines, the solution is infinitely many solutions. Infinitely many solutions, and the condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So intersecting lines, unique solution, correct? Intersecting lines, unique solution. See, when we talk about solution of a pair of equations, we are talking about the common solution. Always the two lines taken alone will have infinitely many solutions. When you talk about the solution to the pair of linear equations, we are talking about the common solution. So when the two lines intersect, there's only one point in common. So we say unique solution, and the condition is A1 by A2 not equal to B1 by B2. When the two lines are coincident, one line lies on the other line, they are coincident lines, then every point on the first line lies on the second line also. So all the solutions are common. That means infinitely many solutions. Infinitely many solutions. Many solutions. And the condition is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. And when the lines don't meet, there are many. The first The first equation has many solutions. The second equation has many solutions, but there is no common solution. There is no common solution. The first line, there are so many points. Every point is a solution to that equation. The second equation also, the line has many points on it. The second equation also has many solutions, but there is no common solution in the case of parallel lines. So no solution, meaning no common solution. And the condition is A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. I made it fast. You all know it. I just made it fast. Okay. I just have a parent waiting outside. Help yourself with this one. I'll just come back. Okay. Go through this and work it out. I'll just come back. Okay. So in this question, we have to find the values of m and n, given that the system of equations have many solutions. So the condition is given. Okay, the condition is that these two equations have many solutions, infinitely many solutions. Given this, you will have to find the values of m and n. So look at the equations. Look at the first equation, 2x plus 3y is equal to 7. That's complete. 2x. So you know the coefficient of x is 2. The coefficient of y is 3. And the constant, if you should bring everything to the left-hand side. You must keep the equation in the form a1x plus b1y plus c1 is equal to 0. You must bring all the terms to the left-hand side. Okay, and then say equal to 0. Okay, so what is c1 then? Minus 7. C1 is minus 7 when you take it to the other side. C1 is minus 7. So as far as the first equation is concerned, there's nothing missing. There's nothing missing in the first equation. Is anything missing? No, 2x, 3y, and the constant is minus 7. We know everything with the first equation. In the second equation, see here, x. This is the coefficient of x. How funny, no? M plus n plus 1. That's the coefficient of x. So if you find the values of m and n, so what are the values of m and n? 3 and 2. So 3 plus 2, 5. 5 plus 1, 6. So this one is 6x. But it looks so funny here. This is 6x. This is 6. M is 3, n is 2. So 3 plus 2, 5. Plus, this is 3, this is 2, and this is 1. So 6x. 6x here looks like m plus n plus 1 of x. So we do not know the coefficient of x in the second equation. Similarly, we do not know the coefficient of y in the second equation. What's the coefficient of y? M plus 2n plus 2. Again, looks funny. So what is m? 3 plus 2n. So 4 plus 2. So 7, 9y. It's 9y. 9y. The coefficient of y is 9. And we'll just work the constant on this side itself. So it is 4 into 3 plus 2, 5. Plus 1, so 21. So it's minus 21 is equal to 0. So yes, so we have to find m and n so that we understand the, or we complete the second equation. In the second equation, we do not know the coefficients of x, y, and we also don't know the constant. So when you find the values of m and n, you can also see the second equation clearly. Okay. So this is the first equation. This is the second equation. Write it in the standard form. Bring all the terms to the left-hand side and say is equal to 0. And then write out the values of A1, B1, C1 from the first equation. The values of A2, B2, C2 from the second equation. Okay. Now see how this is transposed. Please look. The first equation, nothing much I have to say. Second equation, see this one is written as it is. This one also is written as it is. Now this one, when you transpose, you know, what you do, just put this in a square bracket. Just put the whole thing in a square bracket, bring it to the other side. What is it before the square bracket here? Plus, no. So it'll become minus. That's all. Just put the whole thing in a square bracket. So see here, I put the whole thing in a square bracket. This whole thing in a square bracket. And just lifted it from the right hand side and put it on the left hand side. And the sign changes. It's plus here, it becomes minus on the left hand side. If you write it like this, you're wrong. If you write minus 4 into m plus n plus 1, you will go wrong. Because see, or you should write this as minus 1. If you don't put it in a bracket, this will be minus 4 into m plus n, and this plus 1 should be written as minus 1 on the other side. When you transpose. See, I have used a bracket, right? Then this plus becomes minus. Is this understood? Are you studying? Otherwise, what you can do, how many terms are here? 1, 2, 2 terms. So how will you transpose this one? It will become minus 4 into m plus n on the left-hand side. Correct? Correct. Then this plus 1 will become minus 1. You can transpose like this also, but don't do like this. Don't do it like this. Put the whole thing in a bracket like I have done. Put the whole thing in a bracket. This is plus. Just lift it and put it on the left-hand side. Change the sign. Okay. All right, so that's what you see here is equal to 0. Okay, so A1, A2, we understand that, right? Coefficients of X, the coefficient of X, this is A1, the coefficient of Y, this is B1, the constant is C1. And this one is A2, this one is B2, and this one is C2, right? You should write it along with the sign. If it's negative, you should take the negative sign because the standard form is what? A1x plus B1y plus C1 is equal to 0. So if it's minus, you should write the minus sign. Okay. Now, because it's given, the equation has, the system of equations have many solutions, write the condition. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. This is the condition for many solutions. Write that and substitute the values. A1, A2, B1, B2, C1, C2, substitute the values. Now this minus and minus gets cancelled. Okay. So now equate these two. How do you solve? How do you go ahead? Equate these two. So cross multiply and simplify. You get this equation in M and N. Now you can now equate these two, or you can also equate these two. That's your choice. You can do three things. So you can equate this and this, then this and this, and this and this. Do any two of the three. Do any two of the three because we only want two equations. So we got one equation. We want one more. So you can equate this and this, or you can equate this and this, anything. What have I done? I've equated these two. So you can see it here. I've opened the bracket. 4 into m is 4m. See, minus cancels. 4 into m, 4m, 4n plus 1. Cross multiply. And yeah, simplify, you get this equation. Now write the equations one below the other. I have changed the signs because it's minus. Okay, I think I've also written the equivalent of this one. See here, this equation, I want to eliminate n. You understand all that, right? I want to eliminate n, so I've multiplied this equation by 2 and I've written it here. I want to eliminate n, so I've multiplied this equation by 2. 2m minus 2n is equal to 2. And this is the second equation, right? So solve and find the values of m and n. Finished? Done? Online children, completed working this one?
Yes, ma'am.
Okay. Any questions? Goes. Aragama, you can write from here, no? Why you can come here and sit. Okay. Okay, next one. Find the values of m and n if the system of equations have many solutions. Yeah, let's do this together. So what is A1? 3. B1? 4. C1? Minus 12. Minus 12. Correct? Minus 12. See, this equation should be in the answer. This equation should be written as 3x plus 4y minus 12 is equal to 0. And the second equation, m plus n of x plus 2 into m minus n of y. Then what did I say? Just put a bracket. So put a bracket and just lift it and put it on the other side and change the signs equal to 0. Put a bracket. right? Okay, is equal to 0. So now what is A2? M plus N. B2, 2 into M minus N. And C2, minus of 5M minus 1. Now, what's the condition for infinitely many solutions? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So 3 by M plus N is equal to 4 by 2 into M minus N is equal to minus 12 by minus of, correct, cancels. 2 ones are, 2 twos are. Yeah, continue. Make the equations and find the values of M and N. Write down the question. Please write the question and then answer it. Online students, share the equations you've got. Online children, Does it take this long to complete, children? I'm sorry to say that, but new equations consequently taking now. Yeah, what are the equations? Got it? Hasif? M minus 3n is equal to 2. M minus 3n is equal to 2. No. Which one did you equate? This and this, huh? Huh? Tell me. Let's see. We'll work it together. Come on. So what is it? 3 into m minus n is equal to 2 into m plus n, correct? When you equate these two, cross multiply, correct? 3 into m minus n is equal to 2 into m plus n. Yes or no? Okay, next what? No, you don't read from your book. You tell me here. What next? Correct. Ivan? Correct. But you can have it like that, but see, have the variables m and n on one side and put the constant on the other side so that you can solve the two equations. Correct. Correct. Yeah, Hasif, tell me. No, Hasif, you don't read from your book. You help me work. இப்போ சொல்லுங்க 3 into m 3m. Then yeah, then the first equation. What's the second equation? Which one you want to equate? Any two. Okay, so we'll equate these two. So 2 into 5m minus 1 is equal to 12 into m minus n. Yeah. Okay. Minus 12 and plus. Minus 2m plus 2 is common, no? So divide by 2 throughout. Minus m. Divide every term by 2. Minus 6m. 2 by 2 and that's the second equation. Now write these two equations one below the other. M minus 6n is equal to minus 1. Okay, minus m plus 6n. Correct. This is also correct. What are the values of m and n? 5 and 1. M is 5, n is 1. Correct. Got 5, 1. Correct. Got it. M5, N1. Correct. Online children, you're not responding. Please check your answer with what you see on your screen, with my answer on your screen. Finished. All the three finished. You both finished. Online children, if you ask me any questions to be clarified, I'll be happy to help, but no communication from your end. Okay, fine. Next one. Got it? Okay. See, you might have got the equation like this also. I got m minus 6n is equal to minus 1. Change the signs throughout. Minus m plus 6n is equal to 1. Maybe you've got this equation. Maybe. That's correct. The equation you have got, every term in your equation may have the opposite sign. That's also correct. See, this is what you see here. Write every term with its m plus m minus m. That means you're disagreeing with everything. Minus 6n. No, plus 6n. Is equal to mattu agree pannidano. Then minus 1 plus 1. Correct. These two are both are the same. Okay. I'll answer this question. Okay. So I'll give you an equation like now I want you to, so this is a linear equation in two variables x and y. I want you to give another equation, another linear equation in two variables x and y, so that the pair of equations or so that the system of equations have no solution. No solution. Tell me another equation, another linear equation in two variables x and y, so that the two equations taken together, or so that the system of equations meaning the two equations taken together have no solution. Tell me. Minus 14x minus plus 6y is equal to 12. Okay, so this is Akshada's answer. Okay, she says minus 14x plus 6y is equal to 12. Yeah, you want to say? Is equal to minus 12. Minus 13. Okay. Bhavishya. Okay, anyone else? Minus 21x plus 9y 14. Yeah, Vashni. Yeah. Okay, good. Akshada, Jayavashni, and Bhavishya. That doesn't mean others are bad. Others are also very good because we're going to learn now. Okay, so keep your ears and mind open and listen to this. So what's the condition? If the system of equations does not have any solution, what is the condition? For no solution, what's the condition? A1 by A2 equal to B1 by B2, not equal to C1 by C2. Okay, so what you should do, you multiply this equation by anything other than 0. Okay, so say I multiply this equation with 4. So what will you get? Anything 4, minus 4, any number, fraction, root, square root of 2, square root of 3, anything. You multiply the given equation by any non-zero real number. But why would we complicate things? We'll take a simple number. Okay, we'll just take a natural number like 4 or an integer like minus 4. And okay. So supposing you multiply this by 4. What is minus 7x into 4? Minus 28x. What is plus 3y into 4? Plus 12y. What is 15 into 4? 60. Write anything other than 60. You should not write 60. Write anything other than 60. You can write that number itself also. You write 15 itself. To write another equation so that the system of equations has no solution, what you have to do is just multiply the given equation by any non-zero real number. Multiply the x term with that number, y term with that number, the constant also with that number, but don't write that. You write anything other than that. Multiply 15 into 4, 60. I will not write 60. Don't write 60. Write anything other than 60. Write 15 itself also. So what did Akshata do? She's multiplied the first equation by 2. So see, minus 7x into 2, minus 14x, plus 3y into 2, plus 6y. Then she just wrote some random. What is 15 into 2? 30. Something other than 30. Should not write 30. Similarly, that's what. So Jayavashni has multiplied the equation with 3. Now the constant 15 into 3 is 45. No, she's just taken 14. You should not write 45. If you write 45, then it become A1 by A2 is equal to B1 by B2 is equal to C1 by C2. And Bhavishya is multiplied. She's also multiplied by 2. Change the 12 instead of 28, she's written minus 13. Just I don't know if I wrote this minus 7x plus 3y is equal to 15. I wrote. Okay. So to write another equation so that the system of equations have no solution, what you should do is multiply this one with multiply the given equation with any non-zero real number. So say multiply by minus 3. So it's 21x minus 9y is equal to minus 45. Don't write that. Don't write minus 45. Just write 15 itself otherwise. Anything other than minus 45. Okay, so something like 40. Any number you can write. That's it. Now check A1 by A2. What's A1 by A2? Minus 7 by 21. And B1 by B2, 3 by minus 9. C1 by C2, minus 15 by minus 40. So you see that this is minus 1 by 3. Minus 1 by 3. So equal. But it's not equal to this. It won't be equal. When will this also be? Okay, let me not explain too much. You got this? Okay, that's all it is. This is for no solution. If you have to write another equation so that the system has many solutions, then multiply every term by this minus 3. So for the same thing, minus 7x plus 3y is equal to 15. Write another equation so that the system of equations have many solutions. Then you should multiply the equation by any non-zero real number, but multiply every term, x term, y term, and the constant by that non-zero real number. So say minus 2. So it will be 14 plus 14x minus 6y is equal to minus 30. Okay, so what is A1 by A2? Minus 7 by 14. B1 by B2, 3 by minus 6. Minus 15 by plus 30. So 1 to minus 1 by 2. Minus 1 by 2. Minus 1 by 2. Valid? Now for the same thing, if you have to write another equation so that the system has a unique solution. What's the condition? A1 by A2 should not be equal to B1 by B2. So just write, supposing you write, okay, say you write what 14 here. Okay, so 14 here, 14x. What is it? Minus 1 by 2. Here it should not be minus 1 by 2. So just put a 9. Actually, you can just write the immediate numbers, you know, the easiest way. ரொம்ப யோசிக்கவே யோசிக்காம எழுதணும்னா just write the immediate numbers, 8x and 4y. Mostly this will work. Is equal to something. Whatever your mind says. Okay, now see what happens. Minus 7 by 8 and 3 by 4. They're not the same, no? Not equal. The negative and this positive. What's the condition for unique solution? A1 by A2 should not be equal to B1 by B2. Yeah, so nothing much to think. So you understand? I just wrote 8x plus 4y is equal to 17 and check A1 by A2 and B1 by B2. They should not be the same. They should not be the same. That's all. You can write a 2 here, or you can just write y. You can just put a y. See, supposing you feel, what if those fractions, those two fractions, they look different, but they have the same value? Then make A1 by A2 negative, B1 by B2 positive. Then you're very sure that A1 by A2 is not equal to B1 by B2. If you're like a little worried, like what if when you find the decimal value, both of them have the same value? Then the safest thing is let A1 by A2 be positive. If A1 by A2 is positive, let B1 by B2 be negative. So in the sense, it's minus, so make it, now as we wrote it here, like if you make this minus 3x, so this will be positive, right? So let this be minus y is equal to 1. So minus 7 by minus 3 and 3 by minus 1. So definitely not equal. 7 by 3 is not equal to, this is positive, this is negative. A1 by A2 is positive, B1 by B2 is negative. So definitely they are not equal. So this question was given one linear equation in two variables x and y. You have to write another linear equation in two variables x and y so that the pair of equations or the system of equations have no solution, many solutions, unique solution. So for no solution, multiply the given equation by any non-zero real number. But don't the constant, when you multiply, you get an answer. No, don't write that answer, right? Anything other than that for the constant. Many solutions, you must multiply the given equation by any non-zero real number. You must multiply the x term, y term, and the constant by that non-zero real number. That will give you the equation where the system of equations will have many solutions. For unique solution, nothing like that. A1 by A2 should not be equal to B1 by B2. So just write numbers to suit that condition. Sometimes, you know, you will have fractions like, I'm just writing something like this, you know, 7 by 9 by is equal to 15 by. Okay. I don't know. I've just calculated. I don't know if I'm wrong. Let me just work and tell you. So like this, no, I can't say don't see. So 3/4. What will you get here? What's the ratio 3/5 here? Same thing. You're getting 3 by, okay. Okay. So sometimes, when you have fractions like this, it is easy, but it may look difficult. So they'll ask you to check and comment if the system of equations, it can be under true or false or 1 marker question basically. Okay, so you'll have to comment on the nature of the equations. So what kind of solution they have, whether unique solution, many solution, or no solution. Okay, so what should you do? You should work A1 by A2. What is the question? You're given the system of equations. You're given these two equations. And the question is, you'll have to comment if the equations have no solution, many solutions, or unique solution. So for that, what will you do? You should work A1 by A2. You cannot write any condition now because you don't know, right? See, if you know that they have no solution, you can write the condition. If it's given that the system of equations have no solution, then you can write the condition A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. If it's given unique solution, you can write A1 by A2 is not equal to B1 by B2. But here it is check, or you have to find out what kind of solutions the system of equations have. So which condition will you write? You can't write any condition, right? Yes or no? So you should work A1 by A2 separately, B1 by B2 separately, C1 by C2 separately. You can't write any condition. Find A1 by A2, find B1 by B2, find C1 by C2. What is A1 by A2? This is A1 divided by, what is A2? This one is A2, correct? So there's nothing but 3/4 into 4/5. So 3/5. B1 by B2. This is B1. This is B1 divided by B2. This is B2. Correct? B1 divided by B2. So this is nothing but, so the minus will get cancelled. Like minus 15 by 7 divided by minus 25 by 7. No, so this minus and minus will get cancelled. Right? So it will be positive now. So, or if you don't want to cancel, into minus 7 by 25. 7 cancels. 5 3s are 5 5s are minus into minus plus and 3/5. 3/5. And C1 by C2, 15 by 7 divided by 1. So 15 by 7. Now what do you observe? What do you observe? A1 by A2. A1 by A2 is equal to B1 by B2, but it's not equal to C1 by C2. Yeah, so we observe that. So what I'm saying is, if the condition is not given, like if it's not given that the system of equations have unique, many, or no solution, you cannot write, because I have seen children writing A1 by A2 is equal to B1 by B2 is equal to C1 by C2 and substituting and working like that. It's not like that. When nothing is known about the equations, you should find A1 by A2 separately, B1 by B2 separately, C1 by C2 separately. And then you have to observe. What's your observation? A1 by A2 is 3/5. B1 by B2 is also 3/5, which means A1 by A2 is equal to B1 by B2. What else you observe? C1 by C2 is 15 by 7. So it's not equal to them. So not equal to C1 by C2. By observation, now you have framed the condition. So this condition says that the system of equations have no solution. That means what kind of lines? Parallel lines, parallel lines, parallel lines. You must work A1 by A2, B1 by B2, C1 by C2 separately. Observe and then frame the condition. All right. I presented this answer, right? All of us check this one. Okay. Okay, yeah, we'll do this. I want all of you to get this correctly.
Online children use the emoji. Raise your hand. Okay. Niveda, Anirudhan, Blessy, Anugraha, Sabarna, Sadhana. Pratish, are you there? Okay, Hari Pranam. Okay. Are you there, Pratish? Okay. Completed. What are the values of M and N? Okay. Okay. Yeah, correct. Correct. M 5/3, N 1/3. Correct. Correct. Okay. Some of us here in the physical classroom have completed and got the right answer. M 5/3, N 1/3. Not getting any response from the online students. I'm presenting the answer. Please check. Yeah, those who have not got it, please ask me if something, like does not match with what you have in your book. You should ask me. You got it? So I told you the constant, just put a square bracket, bring it to the other side, put a minus sign before it. Minus and minus will get cancelled. C1 by C2 minus minus cancels. And then 3 1s are 3 3s are.
Check now if my answer is also right. Even I could have made some typing mistakes. See, in the time you're waiting for your friends to complete, check my steps. Actually, here what I could have done is I could have cancelled off the 3 and 3 instead of cross multiplying. You can just cancel 3 and 3 here. I've cross multiplied, meaning I've multiplied this. I multiplied like this. Okay, so still easy. You can just cancel the 3 and 3. And now it's 1 here. So cross multiply, you'll get the same equation. The same equation. So here I've divided by 3. So m minus 2n is equal to 1. Solving the two equations, n is 1 by 3, m is 5 by 3. Completed? Hasif? I'll help you. Give me a book. Okay. No? Come here. Others finished. Okay, try the next one. One second. No. The others are simple. 1 minute. I was just talking about the power cut today. Today I was talking, like I think half an hour will sustain. Yeah, this is the next question, children. So the condition is dependent equations. Okay. Theater effect now. Okay, the condition is, yeah, I'm laughing for my own joke. Laugh, no. So one second, I'm coming. Find K if the system of equations are dependent. Just try, just come back. Done writing the question? Okay. Taken the question? Just a minute. Okay. Then I can into the M இது கரெக்டா? அப்புறம் நீங்க அதை கேன்சல் பண்ணலையா? இந்த 3 இதை கேன்சல் பண்ணிருக்கலாம். ஓகே, நீ கேன்சல் பண்ணல. ஃபைன். ஸோ யூ காட் minus 9m plus 9. இதெல்லாம் ஏன் சிம்பிளிஃபை பண்ண மாட்டேங்கிற? எங்க பண்ணிருக்க? அதுதான் இதெல்லாம் minus n plus 1 is equal to இது 2 தான். minus n plus 1 is equal to minus 2n தான். Correct. So you're getting minus n plus 2n is equal to correct. See, a equationல இப்ப m a equationல m பாசிட்டிவ், உனக்கு இங்க நெகட்டிவா வந்திருக்கு. இங்க நீ இந்த 1 இங்க எடுத்துன்னு போனா உனக்கு -1 வரும், எனக்கு +1 இருக்கு. நீ இந்த -2n இப்படி கொண்டு வந்தா +2n, எனக்கு -2 இருக்கு. கரெக்ட். Our equations, they're the same. Signs opposite are good. They're the same then. Correct. Thank you. Yeah. Question number 3B. 3B, yeah? Yeah. Find K if the system of equations are dependent. Finished? Okay. Okay, so in the earlier set of questions, we had to find the values of m and n. Here, find K. So in the first equation, we do not know the coefficient of y. In the second equation, we do not know the coefficient of x and the constant. Wherever K is involved, we don't know that completely. So constant here, we don't know the coefficient of x. And here we do not know the coefficient of y. So we'll have to find the value of K. The condition given is this system of equations are dependent. Dependent meaning? Dependent. Okay. So dependent meaning they have infinitely many solutions. Okay. Now I understand why you're waiting. Dependent meaning they have many solutions. Dependent equations have many solutions. That means A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, so what do we mean by consistent equations? Yeah, okay. This brings us to another discussion. What do you mean by stop writing and tell me what are consistent equations? What are consistent equations? Inconsistent equations. No, I want the definition. Inconsistent equations. Consistent equations, inconsistent equations. Now, supposing I give you two equations and ask you to comment. Okay, comment if the given system of equations are consistent or inconsistent. Yeah. Okay. So since I'm not getting any answer, I just assume that we have to discuss. So consistent equations refer to a system of equations which have at least one solution. If a system of equations have at least one solution, then that system of equations are said to be consistent. If a system of equations have no solution, then they are inconsistent. If a system of equations, that is a pair of equations, a pair of linear equations in two variables x and y, if they don't have any solution, no solution, that means parallel lines, no solution, parallel lines, then that system of equations are said to be inconsistent. But if the system of equations have at least one solution, so at least one solution or more than one solution. See, at least one means what? One or more than one. So when a system of equations have a unique solution or many solutions, under both the cases, they are said to be consistent. Because what's the definition of consistent equations? They should have at least one solution. That means what? One solution or more than one solution. So we have two cases under consistent equations. So consistent equations can have a unique solution, or consistent equations can have infinitely many solutions. Correct? So when a system of equations have only one solution, they are consistent. When they have many solutions, they have solution, right? So they're consistent. When they don't have a solution, no solution, they're inconsistent. And in consistent equations, we have dependent equations. In consistent, we have dependent equations. Dependent equations are consistent equations which have many solutions. And now I'll just write the theory. You finish that answer and maybe you can write down all this. You want help to work? Yeah. Okay. Okay. Louder? Minus the value of k. Okay. Plus or minus 4. Plus 2 minus 4. Correct. Okay. All right. Please stop to listen to the explanation. So the question is find k if the system of equations are dependent, meaning they have many solutions. So write out the equations in the standard form, meaning bring all the terms to the left-hand side. No, don't go ahead of me. Please look at the step where I am explaining. Okay, so you see here, all the terms are on one side is equal to 0. In the second equation, all terms on one side is equal to 0. So this becomes minus 5. This one becomes minus of 8k minus 1 is equal to 0. Okay, that's the first step. Now write out the values of A1, A2, B1, B2, C1, C2. Okay, then because it's given that the system of equations are dependent, that means they have many solutions. So this is the condition for many solutions. Then substitute. Okay, this is the condition for many solutions. Dependent means many solutions. And this is the condition for many solutions, substitute. Upon substituting, minus and minus gets cancelled. Okay. Now, here we have to work, a few cases. So, you can equate these two and find the value of k. You can equate these two and find the value of k, or you can equate these two and find the value of k. All right. All right. So see case 1. 1 by k plus 1 is equal to k plus 1 by 9. So when you cross multiply, k plus 1 into k plus 1 is k plus 1 the whole square is equal to 9 into 1, 9. So k plus 1 is equal to, see, like a square is equal to 9. So what is a? A is equal to plus or minus square root of 9. So a is equal to plus or minus 3. In the same way, k plus 1 the whole square is equal to 9. So what is k plus 1? Plus or minus square root of 9. So k plus 1 is equal to plus or minus 3. So that means k plus 1 is plus 3 or k plus 1 is minus 3. So if k plus 1 is plus 3, so minus 1. Okay, so k is equal to minus 1. So k is equal to minus 4. Okay. Okay, so these are the two values we get for k when you equate these two. Now let's do the next one. Okay, equating these two. So that's what you see here. K plus 1 by 9 is equal to 5 by 8k minus 1. Cross multiply. So I'm not explaining this. Cross multiply. Bring all the terms to one side. You get a quadratic equation. You get a quadratic equation. Now, see, so for you may try to factorize by splitting the middle term. You're not able to find the factors. It's difficult to find the factors. So you can use a quadratic formula. Don't spend a lot of time finding the factors to split the middle term. Don't spend time. Use a quadratic formula. Okay. So this is the quadratic formula. We are finding the value or values of k, right? So we should write k is equal to. If this was x squared, then you should write x is equal to. What was the variable involved in the quadratic equation? So since we have to solve this quadratic equation and find the value of k, it is k is equal to. K is equal to minus b plus or minus root of b squared minus 4ac by 2a. That's the quadratic formula. When do you use the quadratic formula? We use the quadratic formula to solve a quadratic equation, to find the two values of the variable involved in that equation. If x is the variable, we use the quadratic formula to find the two values of x. K is the variable. We use the quadratic formula to find the two values of k. Because we know a quadratic equation can have a maximum of two solutions. Yeah. So splitting the middle term looks difficult. So we're using the formula. And what are the values of a, b, and c? Coefficients. Coefficient of k squared is a, coefficient of k is b, and the constant is c. Everything should be on one side. You're comparing it with the standard form, a x squared plus b, okay, not x squared, a k squared. You're comparing it with a k squared plus bk plus c is equal to 0. This is a standard form. A k squared plus bk plus c is equal to 0, like a x squared plus bx plus c is equal to 0, is a standard form of a quadratic equation in one variable x, correct? Why we used k? Because the variable is k. A k squared plus bk plus c is equal to 0. So what's the value of a? 8. B 7. C minus 46. Now substitute. And you see here, this one is a perfect square. You should know how to find the square root of 1521 using the long division method. Or if you know the squares of the first few natural numbers, then you know 39 into 39 is 1521. See, for you, you might think she's just doing it so easily. How to do the long division? She's not explaining. So you should know the right. You should know the long division method to find the square root of 1521. So that's 39. So on solving, you see, you find the two values of k. All right. Now the third case is equating these two. 1 by k plus 1 is equal to 5 by 8k minus 1. Cross multiply and you get k is equal to 2. Now compare the values of k you get in all the three cases. K is 2 or 4 minus 4. K is minus 23 by 8 or 2. K is equal to 2. So what's the common solution in all the three cases? Working any two cases is enough actually. I have worked all the three. Everywhere I would have worked all the three cases because it's easy for me to check. It's easy for you to check your answers because I see if I do case 1 and case 2 and somebody has done case 1 and case 3. Yeah, so for that reason, I have worked all the three cases everywhere. But as students, you can work any two of the three cases. Any two you can work. You don't have to work all the three cases. You work any two of the three cases. So the common solution will be the value of k. So here, supposing you work the first one and the second one, what's the common solution? K is 2. So k is equal to 2. The value of k is 2. The value of k is 2. Everywhere you can find them. If you work 2 and 3, see here, value of k is 2. 1 and 3 also, when you compare, the value of k is 2. Now, supposing you worked only this, okay, and in the say it's 1 marker and you have some options. So there is one option 2 comma minus 4. There's another option. The values of k, value or values of k. So you have 2 minus 4, then you have minus 23 by 8 and 2. Not x value and y value. Values of k only I'm saying. K is equal to 2 or k is or minus 4. K is minus 23 or 8. My mind is racing. Okay, so you have the options. First option, k is equal to 2 or k is equal to minus 4. That's the first option. Second option, k is equal to minus 23 by 8 or k is equal to 2. Third option, k is equal to 2. And then maybe some other fourth option. So if you work only this, you will select this one. But that's wrong because k is not minus 4. So k is equal to 2 is the correct option. And that you will be able to choose correctly only if you worked one more case. If you worked only the first case, you will think, okay, k can take the value 2 or minus 4. You understand what I'm saying? Yeah, so it is not sufficient to work only one case. It's not sufficient. You should work at least two so that you can compare and the common solution will be the value of k. All right? Yeah. Work this. I don't think you would have worked all the three cases so fast. Yes, 1 and 3. You? Don't you think instead of sitting with folded hands, we can just work case 2? Just for the sake of practice, we'll be practicing how to solve a quadratic equation by using the quadratic formula. Sorry. All the three cases? Okay. So let's see what happens when k is minus 4. Okay. So what will be the equations when k is equal to minus 4? Let's just see if y doesn't work. So it will be x plus minus 4 plus 1. That's minus 4 plus 1 minus 3. 3y is equal to 5. Then k plus 1. So minus 4 plus 1 minus 3, right? Please help me. Then plus 9y is equal to minus 32 minus 33, correct? Now the equations are dependent, which means they should have, dependent, which means a1 by a2, b1 by b2, c1 by c2, all same. So here you get 1 by minus 3. Here also you get, or minus 1 by 3. Here also minus 1 by 3. Here it's not working. You can see when k takes the value minus 4, I've constructed the equations. When k is equal to minus 4, I've constructed the two equations. Here, these are the two equations when k is equal to minus 4. Now, when k is minus 4, these are two equations. But the equations are dependent. That means a1 by a2, b1 by b2, c1 by c2 all are equal. But you can see here, they're not, c1 by c2 is different, right? Yeah. Finish this one. Okay, now we'll do a, yeah, please make a note of this one, children. Please make a note of this. Consistent equations, inconsistent equations, dependent equations. At least one solution, consistent. No solution, inconsistent. Another term for many solutions is dependent equations. Note it down, all of you. Okay. Next question. This is the next one. Find K if the system of equations are dependent, meaning many solutions. So we know the condition, they are dependent, many solutions. So A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So you'll have to work all the three, no, work any two of the three cases. The common solution is the value of K. Yeah, correct. Come on here, show me it. I said work at least two cases. Yeah, when there's only one value for K, that only will be the answer. But you work another case. Yeah. How many cases? Nobody listens. Correct. The answer is correct. Huh? One you got. The value of K is? No. That's what. So it depends on which case you're working. So you've got 2 and 1. Huh? Where have I got 2 and 1? Case 2, case 2. No, I don't have 1 at all here. 2. Okay. Please check your answer. Sorry? No, you're frightening me. There's a different question, huh? Oh, I'm presenting the answer of a different question. Oh, it changed now? Okay, 1 minute. This was a question you've taken and worked? Okay, this is the answer, right? Okay. Sorry. I was presenting a different answer. From the beginning, I was doing that. Oh, it just changed now. Okay. Yeah. Yeah, please check your answer. Yeah, I'll help you. Sorry. Finish the answer and then laugh. He hasn't completed the answer. Okay, completed working, all of you? Online children, done working this one?
Yes, ma'am.
All right. So if the system of equations are dependent, it means they have infinitely many solutions. Consistent equations have at least one solution. So if the system of equations have one solution, they are consistent. If the system of equations have infinitely many solutions, they are consistent. They have solutions, so they are consistent. If the system of equations have no solution, then they are inconsistent. No solution, inconsistent. If they have solution, whether one or many, they have solution, no, then they are consistent. If they don't have any solution, inconsistent. So I have nothing to explain here because this is the condition you'll have to substitute. Then work the three cases. You're cross multiplying. You might either get the value of k directly like this, or you may get a quadratic equation where you'll have to split the middle term and then find the two values of k. So I don't have any role to play here. And then, the common solution is the answer. I told you don't have to work all the three cases. Work any two of the three and the common solution. So here, see, if you work case 1 and case 2, case 2, case 2. Common solution is 2, so case 2. That's it. Oh, let's take a simple one then. Okay, try this. Find the value of k if the system of equations have a unique solution. We'll wind up the session with this one. Find the value of k if the system of equations have a unique solution. It's given they have unique solution. So what's the condition? A1 by A2 is not equal to B1 by B2. I'll present the answer because I want you to take down the steps correctly. So for another now. So bring all the terms to one side and equal to 0. Write out the values of A1, A2, B1, B2, C1, C2. Write the condition for unique solution. Substitute the values. On cross multiplying, you get k square is not equal to 36. K square is not equal to 36. So k is not equal to plus or minus 6. That means for all real values of k. So k should not, see, you should find the values. You should find the values of k. What should be the value of k? You should not say what k should not take. What should be what can be the values of k? So what on working we get k should not be equal to plus or minus 6. K should not be equal to plus or minus 6. So for all real values of k other than plus or minus 6, the system of equations will have a unique solution. K should not be only these two values, plus 6 or minus 6. That means what it can be? It can be anything other than these two values. So for all real values of k other than plus or minus 6, the system of equations will have a unique solution. This is important. You should not stop your answer here because they're asking you to find the value of k, but you haven't found the value of k. You're saying k should not be equal to plus or minus 6. What should be the value of k? It can be anything other than plus or minus 6 to have a unique solution. All right. So this is how we always solve unique solution. I'll just show you one more. The rest I'll share it on WhatsApp. Now see here. In this one, when you work A1 by A2 not equal to B1 by B2, you get 2 is not equal to 5 by 3. And is that true? 2 is not equal to 5 by 3. Yeah, it's correct. 2 is not equal to 5 by 3. That means A1 by A2 is not equal to B1 by B2, irrespective of the value of k. K can take any value. See, this is fixed. A1 by A2, B1 by B2, A1, B1, A1, A2, B1, B2, they all have constants already. They have fixed values already. K is not involved. In A1, A2, B1, B2, K is not involved. K is not involved. So what do you get? You give on working with 2 is not equal to 5 by 3. Okay, so whatever be the value of k, this will not change, right? Because if you have the presence of k here if you have the presence of k, then it will change. But here there's no k at all. And you can see that 2 is not equal to 5 by 3. And this is true. 2 is not equal to 5 by 3 is true. And this one is not dependent on the value of k because k is not present here at all. So that means what? Whatever be the value of k, for all real values of k, the system of equation will have a unique solution because whatever value you give for k, this A1 by A2, B1 by B2 will be the same, no? You give different values for k. What will you get when you work A1 by A2, B1 by B2? Same thing you will get. You will always get 2 is not equal to 5 by 3. This situation will not change. If you give, when you take different values for k, this situation will not change. Because they have fixed values A1, A2, B1, B2, they have fixed values. So it's always going to be 2 is not equal to 5 by 3, whatever be the value of k. So, and this is true. 2 is not equal to 5 by A1 by A2 is not equal to B1 by B2 is true. Because that is a condition for unique solution. A1 by A2 should not be equal to B1 by B2. And yeah, it is not equal. 2 is not equal to 5 by 3. Okay, but what should be the value of k? K can take any value. For all real values of k, the system of equations will have a unique solution. Okay, I'll share this. You can complete this later. Those are just. Okay, this I'll not share, but I think. Or I'll do one thing. I'll just share all this. We have one more, like heading to discuss. The others we have discussed. So in this presentation, we have one more heading to discuss. But I'll share the images. Nothing difficult about this. So you work and understand as much possible, or you will understand actually. But we'll just discuss this in the next class. Okay. Yeah. So I'll share all these images on WhatsApp complete as assignment. All right, children. So that's it for today's session. Thank you so much. Online children can leave the call. And thank you everyone here. Good night.
Thank you, ma'am.
Thank you. Good night.